So let's go over the problem put call parity arbitrage. Put call parity establishes a fundamental no arbitrage relationship between European calls and put options with identical strike prices and maturity. And so the main thing to take away from the first sentence is that this is for European calls and puts, and we have to have an identical strike price and maturity. So we're given this equation and we're trying to find any market inefficiencies. How are we going to do this and create a function that takes in this potential information from left to right and create profit? First, let's go over what are the variables actually meaning? Like what is C, what is P? So clearly C is call price, P is put price, S is spot price, which also is the underlying stock price of the asset. K is the strike price, R is the risk-free interest, and T is time to expiry. So now we have these variables. What we need to do is determine if there's any way to make money from these variables. So let's put them in the exact formula you see over here. So this right here is the present value. We have the spread over here, and we have the right side equation, left side equation. And all we have to do is determine if we're able to make any sort of money from this. Meaning if we move the right side of the equation to the left, is this greater than 0? If it is, so let's say we have 5 minus 4. If it is greater than 0, that means we can make money from this arbitrage opportunity. We can make $1, right? And so that's all we're trying to find. And when it comes to using pandas, all we have to do is ingest all of this, ingest it into a pandas data frame, and basically calculate, is the left side and right side above 1 when we use the absolute value, similar to this. So we just take this equation, we dissect it, and we determine if it's greater than 0. Another thing before we get straight into the problem is that this is using risk-free interest, and we also don't have dividend information. And so in future problems that relate to put call parity, we may add that and make it a medium problem. So keep in mind there's other extensions to put call parity, uses dividends and uses discrete interest. Keep in mind the result is model-free, meaning it does not use the Black-Scholes model, even though they're tightly linked. And it doesn't use binomial options pricing model, any sort of volatility calculations. All it's doing is using the principles of no arbitrage. So as long as you know that, you have a lot of context to understand what put call parity arbitrage means. Let's get straight into the problem. Also, at the bottom of my spreadsheet that I'm going to share, there is a small little diagram where you could play around with it and check the opportunity for arbitrage and the theoretical speed required for it. So we have this problem right here. And this problem is basically just telling you to take in the data frame, ingest it, find the present value of the strike, calculate put call parity deviation or the spread of the put call difference, and then return the actual profit opportunity as the output. So let's start coding it. So this is market data, and we have this market data, and all we're trying to do is find the call price, which is going to be put price, stock price, strike price. We have the risk-free interest rates, and then time to maturity. And so we have all this information. Following to-dos makes it easy. I'm just trying to be as verbose as possible to make it so it's easy to understand what is going on, and it's easy to understand what type of equation I'm using and how the process, how everything is working. So now we have to calculate the present value, which is PV of a strike price. And the present value, as previously said, is K times numpy exponent, Euler's number, and then negative R times T. And once we have that, let's get the left-hand side and the right-hand side. Left-hand side is going to be call minus put. Right-hand side is going to be KS, which is spot price, times present value, minus present value. And once we have present value, we can use this to determine if there's any arbitrage opportunity. So let's create a column where in the data frame, which returns arbitrage profit. So after we create this column, we return it, And let's see what we get. So I accidentally put DF instead of MD, and call price is not the same. So this doesn't actually account for when there is no market data, where we would return an empty data frame. And once we account for both of the variables, we should be able to get the correct output. Let's submit it. And we got it right. So this was the entire code. And I'll also share with you guys the notebook that I used at the beginning. So hopefully you guys enjoyed and keep min bidding.